Hi team, I've got another problem for us to look at that's going to involve power. So in a previous video we already took a look at this particular equation and we were looking and really paying attention to the units that we were in. Now I'm going to give us a slightly different problem because it's really important to understand that this energy can come in a lot of different ways. So we learned in our first unit that energy has lots of different forms. It can be transferred in a lot of different ways. I'm going to take a very different approach from our lifting a rock problem. And I'm going to take an example where somebody is moving and they're only moving in the horizontal. That's important. We're trying to keep this as simple as we can. How much power does an Olympic sprinter use if it takes them 3 seconds to get up to their fastest speed of 10 meters per second when starting from rest? This particular sprinter has a mass of 60 kilograms. I'm going to come in and I would like us to highlight the important numbers here. 3 seconds. Hopefully we recognize that that's a time. I see 60 kilograms over here. To me, I'm going to immediately understand that that's a mass. And then I also see over here this 10 meters per second. That's a speed. Hopefully you are thinking along the same lines that I am and thinking that we must be dealing with kinetic energy. So this particular sprinter starts from rest. That was told here in the problem statement. And so what they're doing is they're gaining a certain amount of kinetic energy. Kinetic energy, again, we've practiced this, is 1/2 mv squared. And so in this particular case, the kinetic energy that is gained by this sprinter is going to be the number 1/2 or 0.5 multiplied by 60 kilograms multiplied by 10 meters per second, and then I'm going to square that. And so 10 squared is 100 times 60 is going to be 6,000, and then divided by 2 or times 0.05. And so this is going to be a kinetic energy that is equal to 3,000 joules. Because remember, if I'm in these correct units, I will get joules out when I do this. Okay, now that I know that, I'm going back to my power equation. Power is equal to energy divided by time. This time, this energy, because it's what I'm interested in, is kinetic energy. So this is going to be power is going to be 3,000 joules divided by the time. And I have to go way up here to find what my time is. So 3 seconds. 3 seconds. Or I could have just written an S. So when I do this mathematics, I'm going to find that power is equal to 1,000. And if we remember our correct units, this is going to be in watts. Okay? So this particular sprinter was able to exert 1,000 watts of power and able to get their body moving up to speed. I'm going to just show this because we are going to do some unit conversions on this at some point. This particular power, this is a nice easy number. There's a unit conversion that says that every 1,000 watts is equal to a kilowatt. And so this 1,000 watts is going to be the same thing as a kilowatt, 1 kW. And saying either of these is correct. So 1,000 watts or 1 kilowatt. All right, hopefully that made sense.